Today we're going to kind of go off the road, and I'm going to introduce you to this new concept before we move forward, because it seems like they just kind of jump into the next part of fractions, and I want to make sure you have a foundation in it. So far we've learned that when we add fractions together, there's something that we always do with the boxes. And what is that we do? How do we know what to do with the boxes? How do we know how big to make them?
Well, you look at the 4 on the bottom, like the bottom number, and then so you're going to make 3 lines, so it'll give you 4 spaces.
Okay, so you have to look at the bottom number. What is that bottom number called? Look at the denominator, and in our first number, the denominator is 4. So you go over 4, and then you go down 3. And then you do that again. Why do we do that? Why do you think we do it that way? Why don't we just say 3 plus 2 is 5 and 4 plus 3 is 7? Why can't we do that?
Because if you were to actually do it on here, you would get a way different answer, and you don't add the denominator.
Okay, you can't add the denominator, so how come we're able to add these? Why do you think we're able to add these once we put them like this? Is this one still 3/4? Is it still 3/4? Why wouldn't it be? Has it changed?
Because you put those 2 lines from the 3rd over to the 4th, so it changed. Now you don't have 3/4.
How many do I have? Huh? 9/12. Can I leave my number like that? What's wrong with that number? Tariana?
The thing that is wrong with that number is that you have to add it to
Maybe. So you mean now I can add this one. Let's see, how many do I have on this one? The second one. The one under 2/3. Can I add those? Why can I add those now? Because the denominator is the same. If I reduce 9/12, what would I get? Does anyone know? 3/4? Oh, look. Here it is right here. If I reduce 8/12, what do you think I would get? 2/3. But sometimes you have to multiply what you're working with so that you end up with a number that both go into. Does 4 go into 3? Does 3 go into 4? Evenly? 4 times what equals, or 3 times what equals 4?
3 times 1?
Does 3 go into 4 evenly? No. Does 4 go into 12 evenly? Let's look at all the numbers that 4 goes into. So we have 4 times 1 equals 4. 4 times 2 equals 4 times 3 equals, let's try 3s. 3 times 1 equals 3 times 2, 3 times 4, or 3 times 3, sorry. And 3 times 4. So when we draw these boxes, our goal is to actually find the smallest number that both of them go into. And when we multiply them out, we find that 12 is the smallest number they go into. Do you see how that works? So the options you have are to sit and draw the boxes, or you could list out the factors. Or actually, it's not the factors, it's the multiples. Or you could do it the way I'm going to show you today. So boys, you probably want to pay attention and don't make me regret letting you sit by each other. So we're going to talk about the least common denominator. The least common denominator is the smallest number that both numbers go into. And there's a little trick I learned in junior high that my math teacher showed me. You can find the greatest common factor. The greatest common factor is the biggest number that goes into a number, and the least common multiple is the number it goes into. You're going to do just like what we've been doing. Eyeballs up here. Does that look familiar so far? Uh-huh. 6 and 4. What do I do with that? Okay, and if I don't know the biggest number that goes into both, I can start with 2, 3, or 5. Because I know that every number that ends with two goes into it. That would work with that, wouldn't it? And I know that any two numbers that I add together, if 3 goes into the sum of them, added together like we talked about yesterday,